Hello dear students, welcome to Byjus Exam Prep, and I also welcome you to this class, that is Time Complexity Part 2. I am taking this under this How to Start Algorithms course. Okay, and before starting, this is about me. If you do not know about me, myself Sridhar I am having 20 plus years of teaching experience, and from past 1 year I am associated with Byjus. We are working on a different project, that is recorded content. We created visualized animated content, my dear friends. Okay, and these are all my achievements. And under Byju's Exam Prep app, learn with video lessons. You will find all these courses recorded by me, my dear friends. You can find all these courses recorded by me. Am I clear? So let me start with the class. Okay, the introduction happens regularly. Hope all of you can hear me. My voice is loud and clear. If you have any doubts or any issues, please let me know. Now let me continue with the results first, which we discussed yesterday. Then we solve interesting problems today. Okay, so this is the first result which I explained. Whenever you are having for loop with some statements, constant number of statements. So I am not writing statements, my dear friends. So here the for loop is starting, say, from I is equal to 1. See here, generally in algorithms course we generally use this index from 1. Maybe in C programming language the index may start with 0, my dear friends. Here we are talking in a general sense, that's why you don't worry about that much, because plus or minus constant hardly matters. So if you observe I is equal to 1, I less than or equal to n, I is equal to I plus c, how many times the loop iterates? Now you must ask me, sir, it's not exactly n. As I told you, the lower order terms are removed because their contribution is negligible, and the coefficient of highest order term is ignored because it is a machine dependent constant. Okay, so we generally ignore those and we write this abstract value. Okay, because it is an estimate, it is not exact value. We need to understand that, right? And even here from n to 1 you are going, and every time you are subtracting a constant value. Even in this case we can take it as n times. So whenever you are having this particular for loop which is contributing highest, in that particular case the time complexity is simply theta n, my dear friends. Am I clear? Now that is the first rule. Now the second one and very important rule here. I is equal to 1 and I less than or equal to n. Now what is happening, sir? Every time you are multiplying the value, current value of I with a constant value. It may be 2, it may be 3, or it may be any constant. This C must be constant, my dear friends. Hi Abhi, good evening. Very good evening, sir. So whenever this is constant, this will iterate how many times? Log n times. See, my dear friend, log to the base, log n to the base 2 can be simply written as Lg. Am I clear? Please remember. Not only that, if you are going from n to 1, n down to 1, and every time you are dividing by a constant, even in this case, the number of iterations, ignoring the lower order terms and the coefficient of highest order term, log n times. And in this particular case, the time complexity is theta log n, my dear friend. See, there is nothing wrong if you write big O of log n, my dear friends. Whenever it is theta, you can write big O. But whenever it is big O, you cannot write theta. Please remember that. Log n, wonderful. Sir, you will teach full course of algorithm on YouTube. See, my dear friends, I will try to take up some very important concept, definitely. Okay, all the concepts will be covered here and there. Okay, some classes are going on app, some classes are going on YouTube. I'll plan some course, my dear friends. It depends on how many people are interested. If most of the people are interested, show interest, definitely I'll come up with the course for sure. Okay, I need more number of people showing the interest. Okay, otherwise I'll be coming up with anyhow some good concepts every now and then, my dear friends, for sure. Base will be seen as, sir. Yes, my dear friends, that's what. The base of logarithm does not matter. Am I clear? So that's why we write log n. That's why here also I not written. If you want, you can write log n to the base c, but base of logarithm does not matter asymptotically. When you're talking asymptotic notation, the base of logarithm hardly gives you a constant factor, and that constant factor is machine dependent issue, so we ignore it. Am I clear? Hope you understand. Right. So that is the second rule, my dear friends. Now the third, very interesting rule. Third rule, see this carefully. For I is equal to 2 to n in powers I power c. See, every time whatever the value of I, you are raising it to the power of a constant. Okay. So yesterday I derived this, my dear friends. Those who missed the yesterday's class can go back and see that particular video, my dear friends. We discussed that in detailed manner. And whenever it happens, it is log n to the base c. If you want to write exactly, that's why I am writing log n to the base c. Even if you write log n, there is nothing wrong, my dear friends, asymptotically. Not only that, from n down to 2, every time you are taking cth root of I, that particular value, even in this case, the complexity would be log n to the base c. That is, this many times it iterates approximately. This many times this loop iterates approximately. We generally write this many times. And if you write the complexity, it is theta log n. Here, you don't try to be very specific like, log to the base 2, log n to the base c. No problem, my dear friends. Okay. Suppose instead of 2, if it is 3, then here we will get 3, my dear friends. That's it. Suppose here if I put 5, what happens? This will be 5. That's it. Nothing more than that. Okay, as clear, sir, we will support you, sir. Okay, it's not supporting me, my dear friends. If more people are interested, I am interested in taking more classes. That is the idea. Am I clear? Hope you understand. Now let us start with problems. Now today we solve problems. Okay, I'll take up different problems, my dear friends. I'll try to cover most of the variations which were asked in GATE or maybe asked in the future GATE. Okay, all the different variations I am going to cover now. Clear? Now look here. X is equal to 0. For I is equal to 1 to, see up to where you are going. It is not n, it is up to n square, and every time you are multiplying I with 2. See, we know this rule. For I is equal to 1, I less than or equal to n, I is equal to I into 2. For this we know the complexity. What is the complexity for this? Theta log n. But instead of n, what is there? N square. Therefore, what is the complexity? Please write down the complexity, my dear friends. I want to see answers. Okay, please write the answer. AB, thank you. Please continue, sir. Please solve the problems. Okay. Now please tell me what is the answer. Today all questions, I will be discussing different variations. Almost all GATE questions will be covered. Okay, all variations. Of course, dependent variations we will do it tomorrow. Tomorrow also we will be solving problems on time complexity only. Am I clear? Yeah. Who is answering this? Yay, log n. Beautiful, AB. Now look here. What is happening here? Instead of n, it is n square. So the complexity would be theta log. See, if it is n, it is log n. But instead of n, what is there? N square. So you get theta log n square. But that is nothing but, because log a power b can always be written as b log a. B log a. So if you do not know the rules, we should always write down and remember them. Am I clear? So what is the answer, sir? 2 log n. So 2 is a constant that can be ignored, therefore theta log n, that is option A, my dear friends. Wonderful. Second question. Please try to answer this question. Please try to answer. Hi, Manshankar Tiwari, sir, if possible, share PDF, please. My dear friends, they are very simple loops. Okay, I generally suggest students to write down. If you write, you will remember more. Okay, I'll try to see how to share the PDF. Okay, because in Telegram channel or in other places, I try to share the PDFs. Okay, but please write down, my dear friends. Okay, that also we'll plan for sure. What is the answer for this? Who is answering? What is the answer for this? Right. Now look here. Same story. I every time multiplied by 2. The current value is multiplied by 2 and we know the same rule we can apply. But here we are going up to 2 power n. So if it is I is equal to 1, I less than or equal to this n, I is equal to I into 2, same rule, then we know the answer is log n. But in place of n, what we are having? In place of n, you are having b for bha. Very good. 2 power n. So the answer for this would be theta log 2 power n. Theta log 2 power n. And that is nothing but, because log 2 power n is nothing but n log 2. Here log 2 is constant, so we can ignore the constant. So the answer for this is theta n, which is option B, my dear friends. Which is option B. Got it? The next problem. But here this time the value of I every time multiplied by 3, not 2. Instead of 2 we are multiplying by 3, then what happens? What is the answer in this case? Same story or different story? See, if you want, we can understand this in the way we understand the regular derivations. That way also you can prove this. So I'll prove that way also, or you can use logical method, because whether it is I is equal to I into 2 or I into 3 or I into any constant, the answer would be log of this number. Maybe in this case it would be log 2 power n to the base 3. Am I clear? So in that particular case it would be n log 2 to the base 3. Whatever it is a constant. Therefore the answer for this must be theta n. Am I clear? So answer for this must be theta n. It's not n log n, my dear friends. C is wrong answer. Okay? It is wrong answer. Now let us try this, the derivation method. See, my dear friend, I value starting with 1. And every time what is happening, the value of I is multiplied by 3. So next time it is 3. Next time it is 3 square. Again when you multiply with 3, it is 3 cube. If you continue this way, how long you have to continue your journey, sir? Till you reach 2 power n. Till you reach 2 power n. And you do not know when you reach 2 power n. Let us assume that at kth term you reach 2 power n. At kth term you reach 2 power n. And what is kth term? It is a geometric progression. The kth term is given by 3 power k minus 1, which is equal to 2 power n. Therefore, the value of k minus 1 is equal to log 2 power n to the base 3, and that is exactly what I written. Am I clear? So instead of 3c is given, here c will come. That's it. So this is nothing but n into log 2 to the base 3. Constant coefficient can be ignored. Therefore, the answer for this is, or the time complexity for this is theta n, my dear friends. That is option B. Hope you understand. All of you able to follow? Any doubts? Please do ask me, sir. Clear? The next one. What is the answer for the next problem? What is the answer for next problem? Thank you. Very good, AB. Very, very good. Okay. Nice. The next problem. What is the answer for this problem? What is the answer for this? Option D. Okay, very good. So you're just seeing for loop, but sometimes when you use together with the programming language, we also need to understand the statements in the programming language. Okay? See the break statement. What break statement will do, my dear friends? It will terminate the loop. the break statement terminates loop. Therefore, what happens? Only one time you enter the loop and you come out of the loop, my dear friends. So the complexity for this problem is simply constant, theta 1. So that is option A. Shubham Gupta, very good. Option A is correct. Okay? Very good, sir. Oh, I have done a mistake. Very good. No problem. Let us see the next problem. What about the solution for this problem? What about solution for this problem? See, they are all very simple problems. Small mistakes, generally people do it. If you can fix the linear loops properly, we enter into the nested loops. Okay, the combinations. In the nested loop, we can discuss independent loops as well as dependent loops also, one after the other. So I'll be discussing the time complexity in detailed manner. Those who can understand today's, yesterday's and tomorrow's class completely, you can solve almost all problems which were appeared in GATE. So I may not be writing GATE here, sir, but some of these questions are GATE questions only. Am I clear? Like that. Very good. D. Let us see. See, continue. It will just skip the rest of the statements in the loop, my dear friends. Suppose after continue, suppose there are some more statements, those statements will not be executed, but the loop continue. That is, from here, directly you go to the next increment, my dear friends. So, it's not like break will terminate the loop, whereas continue, just skip the remaining portion, whatever remaining part to be executed. Whenever you find the continue, okay, what happens? You move to the next iteration of the loop, my dear friends. Loop will not be terminated, just that particular iteration stops and rest of the statements are skipped and you move to the next increment part. Okay, so because of this, we just need to consider this for loop, and what this for loops do, we all know it. One increment of +1, +2, +3, whatever it is theta n only. So answer is D, my dear friends. The next problem. What is the answer for this? Next problem. Very good, Shubham, very good, AB, and Kannababu also very good. All of you doing nicely, properly, perfect. Next problem. What is the answer for this? So this is not coming under any rule, okay? So that's why one should always understand proper procedure. Am I clear? Every time you want to solve any problem just by some basic rules, it will not be sufficient, my dear friends. We should always understand the methodology. So whenever you struck, we have to solve. So we are starting with I is equal to 1. Every time, very good, AB. Every time you are adding n by 3 to it. So 1 plus n by 3. Next time 1 plus n by 3 plus n by 3, that is 2n by 3. Next time 1 plus 2n by 3 plus n by 3, because 2n by 3 plus n by 3 is n. So we get n plus 1, that means loop terminates. So how many iterations happened, sir? 4. See, this loop, the condition is verified 4 times, you enter the loop 3 times only. So constant times, 4 times you can write or 3 times, constant times you can mention. See, don't worry about exact number of times, my dear friends. If at all they ask, you can see 1, 2, 3. 3 times you enter and 4th time you will not enter, you come out of the loop. Okay? So constant. So complexity for this is theta 1. Wonderful. Perfect. Only 4 times loop will run. Wonderful. Kannababu, wonderful. Very good, sir. Very good. The next one. See, all these problems are created in a systematic manner, my dear friends. Okay? These are all created in a systematic manner. I not just created taking from here and there. I just followed some order, okay, to create these questions, so that if you understand, you can solve any problem very easily. Generally, I follow that particular methodology for solving or doing any topic. Okay, please take up this problem. A, for this also A. See, it's not necessary that always we get for loop only. Okay, sometimes the loop can also be, that is the loop which is used can also be while loop. Okay, This while loop is exactly same as your for loop, sir. Because in while loop what happens? The initialization happens outside the loop. Only the condition verification happens here, whereas updation happens inside the loop. It is equivalent to the following for loop, my dear friends. I is equal to n, I greater than or equal to 1, I divided by is equal to some statement. Here statement is simply this x plus plus. Is the idea clear? B for Bihar, AB says Bihar and Kannababu says ye. How many years? B. Okay. Now let us see. It is same as n to 1 by dividing the value every time with 2. So obviously it is log n, which is option B, sir. So sometime instead of giving for loop, you may get while loop also. You should know that. Am I clear? Because in while loop, the initialization happens outside the loop, condition is verified within the while condition, and the increment happens inside the while loop. You just need to remember that. Got it? The next one. What is the complexity of this C code segment? Next problem. B is correct, AB. B is correct for the previous problem. Next problem. What is the answer for this? See, I created around 25 to 30 problems for today's class, my dear friends. So, it depends on your interaction, how quickly you do it, that quickly we can complete the story. 25 to 30 problems are there, totally. Am I clear? So, your answers, B, Kannababu says B. Okay, very good. Yeah, any other answer? Any other answer? Yeah. Now let us see this. Here also, it is not in our rule. We start with 1. Every time you are multiplying with n by 2. So 1 into n by 2, n by 2. Now n by 2 again multiplied with n by 2, you get n square by 4. N square is more than n or not? N square is more than n, therefore stop. Break. So, how many times loop iterates? Constant times. So, the answer for this is also constant. Theta 1, my dear friends. Is the idea clear? Hope you understand. So, this is about linear loop. Yesterday I given some rules. Okay. Please revise those rules. And I solved some variants here. Now, we move on to the nested loop. And in nested loop, there are two types of looping happens. One is independent nested loops. That is, the loop variables does not depend on each other. The loop conditions or whatever it is, they will not depend on each other. They are independent loops. Okay. So, for example, 20 people is watching. That is great. Good. Okay. See, even if 1 is watching or 20 is watching, I will deliver my lecture with the same energy, my dear friends. Okay, I love teaching. This is my passion. Okay, thank you for watching my class, my dear friends, all of you. Okay, why theta 1? For which this one? Which problem? This one? Constant, na? How many times the loop iterates? Just 3 times. Therefore, theta 1. Just theta 1. Now, this is the idea of independent nested loop, my dear friends. Now here, see, this is I, loop variable I, and here it is j. And I and j values does not depend on each other. Such loop is called independent loop. Such loop is called independent loop, my dear friends. Now you see this dependent nested loop. Maybe tomorrow we discuss the problems on this dependent nested loop. We need to be little careful with this. Of course, there is a shortcut for that, how to handle this dependent nested loops. Am I clear? That we'll discuss tomorrow, but let us understand what is this dependent nested loop. Okay, sorry. Now look here. Here I value, that's for the first for loop, outer for loop, I is the loop variable, my dear friends, whereas inner for loop, j is the loop variable. But you see, j depends on I. The value of j depends on I. The value of j depends on I. Thanks, thank you. Very good. Dear friends. Okay, Nishant Fatima also answering. I am sorry, some options I am not seeing. Very good, sir. Very good. You are all doing great. See, this is your work, my dear friends. My work is say things in a proper systematic order, and please remember this, whenever you learn anything in a systematic order, you will never forget and you can ace any examination very easily. Please remember that. So this is called dependent loops. So we'll talk about dependent loops later, but today we talk about independent loops, my dear friends. Now this is independent nested loops. Independent nested loops. Questions will be something like this. What is the complexity of the following C code segment? Generally in GATE examination also similar type of questions will be asked. Now we are having this for loop. Now here if you observe, I value varying from 1 to n and I is equal to I plus 1, and inside loop j value varies from 1 to n, j increments by 1. See my dear friend, whenever you get such independent nested loop, first let me give you the systematic approach, then I'll give you shortcut. Both the methods I'll give you. See, whenever it happens, number of iterations if you want to calculate, you can use double summation notation. Am I clear? See, the outer loop variable varies from where to where, sir? From I is equal to 1 to n. Whereas inner loop variable varies from where to where, my dear friends? Inner loop variable varies from j is equal to 1 to n. And how many statements are there inside the nested loop? Only one statement. So the time complexity can be approximated by solving this double summation, my dear friends. If you can solve this double summation, you can get the time complexity. See, first let us solve by this general methodology. You will understand the importance of this when you get some complex problems. Otherwise, generally using our regular rules, we can get the answers, my dear friends. Am I clear? Now if you observe this, the inner loop, it is like j is equal to 1 to n. So what is that? 1 is added to itself how many times? 1 to n times. That is n times. So 1 plus 1 plus 1 n times is n. So this value will be n. So inner loop is completed. Because inner loop does not depend on outer loop, you directly get the answer. Now this n, see here the loop variable is I. And n does not depend on I. You can take n outside, my dear friend. N can be taken outside. Sigma I is equal to 1 to n. Now it is constant. Again sigma 1 is nothing but how many times the loop iterates, or how many values you are adding, sir, or how many times you are adding 1 to itself. N times. So that you are going to get n into n, which is n square. And that is the answer. Is the idea clear? Theta n square. Wonderful. Wonderful, sir. Very good. Very good. So this is the methodology for solving. This is correct methodology or proper approach. Okay? Or good approach. Of course, the other approach which I am giving is not bad approach, my dear friends, but this is the proper way of solving it. Okay? Now let us understand the simple way of solving it. Now you see this loop iterates how many times? Whenever you get independent loops, you see each loop. How many times it iterates? The outer loop iterates n times independent of inner loop. And inner loop iterates n times independent of outer loop. So directly we write the answers for such problems, sir. Tn is equal to theta n into n. Just multiply all those values, you are going to get the required answer. Theta n square. Product of all these values. Okay, product of all these values will give you the answer. Because for every I, inner loop iterates, for every one value of I, inner loop iterates n times. Therefore, n times I varies how many times the nested loop iterates? N into n, n square. That is a simple mathematical logic for this, nothing more than that. Hope you understand. Theta n square, wonderful, wonderful. Okay. See, for the first problem, I want to tell the detailed procedure. This is actual procedure, sir, but we use this methodology. Am I clear? So let us take next problem. Of course, the same problem, sorry. Of course, in this case, you can simply say n times. See quickly how you solve in the examination, sir. N times, and you say n into n, n square. So theta, Tn is equal to theta n square. But I generally see people always write big O of n square for this. As I told you, big O is the safe notation. Big O is the safe notation. Yes, there is nothing wrong. Remember, whenever it is theta, you can write big O. But whenever it is big O, we cannot write theta. So people always take the safe notation. What is safe notation? Upper bound notation is safe. Okay? So generally in examination, you say maximum I can get this many marks. Something like that, no? Like that. So safe notation it is. Got it? Wonderful. If 3 nested loops are there, same story, sir. For every loop, count number of iterations, multiply them. You will get the answer. That problem also I will show you. We have that problem also with you. Next one. Now here again, nested loops. Independent or dependent? First you have to see whether this J depends on I. No. Then it is independent loops. This loop, that is the loop which you are having, nested loops, that is, we call it as independent nested loop. Got it? Now outer loop iterates how many times? Remember the rules. First rule which I given, I is equal to 1, I less than or equal to n, I is equal to I plus c, I plus 2, I plus 3, whatever it is, theta n or n times. I is equal to 1, I less than or equal to n, I is equal to I into c, 2, 3, whatever it is log n. These two you should remember. Okay, instead of theta n, what I say is how many times it iterates, let us write down. How many times it iterates? This iterates n times and this iterates log n times. Hope you understand. Yes sir, clear. Theta n log n. Wonderful. This is n times and the second one is log n times. Therefore, what is the complexity for this? Theta n log n. You can say, don't worry, theta, it is theta notation. Perfect. For this you can write theta notation, sir. For the simple loops. Okay, you can always write that. Okay. See, actually under, the Learn with Video lessons, we are having some algorithm videos where I try to do these concepts in a more detailed manner. All the derivations I done. Okay. Generally in classes, such derivations are difficult to do it. Because there are many people, not everyone is interested in derivations. So I try to do all type of variations and derivations in the Learn with Video lessons. You can see some of those videos for free, my dear friends. You just need to download BP app and Learn with Video lessons. There is some limitation is there. You can take these interesting topics like asymptotic notations. These are all mathematical. Okay, and I am a mathematical expert also. So those topics were done in a very detailed manner by me, even with derivations and all. Am I clear? You can go through that. Right, theta and log n is the answer. The next one, ready to go. What about this? What is the answer for this? Very good, AB. Very good. Wonderful. Wonderful. You're rocking. Okay. Sir, please, independent nested loop. Oh, sorry, Rangababu says something. Sir, please say the independent nested loop. Please, Sayana. See, dependent, tomorrow also class continues, sir. Today's class and tomorrow also same, time complex. I just taken 3 classes so that I can leisurely do all the variants. As many variants as possible. Am I clear? So, I am not in hurry. So, dependent, first you need to understand independent. For dependent, let us complete this. Then we will move on to that. Okay? One by one after the other we will answer. Okay? Right, next problem. Who is answering this? Who is answering? थोड़ा difficult problem दिया था. See my dear friend, to confuse you sometimes 2 into I may be given as I plus I. I plus I is equal to what? 2I. Even in C language, the assignment is right to left. So 2I is assigned to I. Am I clear? So that is what we need to understand. Generally, just to confuse you, I just given like this. It is equal to 2 into I only, my dear friends. This is also 2 into J only. 2 into J only. Am I clear? But hope you understand. So it is same as your for loop. The second rule. Okay? I is equal to 1. I less than or equal to n. I is equal to 2 into I. So what is it? The first loop iterates log n times. Second loop also iterates log n time. Wonderful. Theta log square n. See, you should write this as AB de Villiers. Okay, log n whole square, fine. There are 2 ways of writing. You can write theta log square n is what is it? Okay, you written wonderfully. I think you have written this perfectly, sir. That is also called log n whole square you can write. But there is something like, theta log n square you should not write. This is wrong. Be careful, this is wrong. Okay, you written correctly. You written correctly. Correct. That is correct. What you written is perfect. I don't have any problem. Got it? Agla samasya. 12th problem. We are only at 12th problem, sir. I taken around 25 problems. Now I is equal to 1, I less than or equal to n, I is equal to I plus 1, j is equal to 1, j less than or equal to n, j is equal to j plus 1, and I cleared your doubt. I come up with, okay, wonderful. 11th problem, my dear friends, this is same 2 into I. This rule, Kannababu, you just need to say, correct? Log n square is wrong. Fatima, log n square is wrong. This is wrong, Fatima. If you write log n square, this is the meaning. You should write log n whole square you can write, but log n square you cannot write. Okay? If it is printing mistake, no problem. See, Kannababu, here it is for I is equal to 1, I less than or equal to n, I is equal to 2 into I, or 3 into I, or 4 into I. Any constant I, this will iterate log n times. In the beginning of the lecture, I given this rule. I just followed the rule, nothing more than that. Nothing more than that. Am I clear? I just followed this rule. And inner loop also 2 into j. Same thing. Log n whole square. That's it. Got it? All of you able to follow? Yeah, next one. 12th one. What is the answer for this? Theta n cube. Wonderful, Fatima. Okay. Okay, if it is by mistake you done it, no problem, sir. I always tell this. Dare to do mistakes. Care to correct it. The same mistakes you should not repeat. Okay? If you do a mistake, don't worry. It is part and parcel of the game. It's a game. You are playing it. There are some mistakes happens, let it happen. But remember and don't repeat it. Okay? That is important. Now if you see outer loop, n times. See, whenever they are independent loops, generally this should happen from innermost loop to outermost loop, but any order you write does not matter because they are all independent. Am I clear? Strictly speaking, we should write from innermost loop to outermost loop. Like that it should go. Okay? N times. This loop also iterates n times, and the third one also iterates n times. N times, n times, n times. So what is the answer? You remember any famous dialogue? N times, n times, n times. Okay? Hope you understand. So the answer for this is theta n cube. Simple problem. See, now what I am doing is I am going to give you some variations. All the rules you mix and match here in the 3 nested loops, 4 nested loops or 10 nested loops, my dear friends. You can solve. Different variations can be solved. But be careful. Not always they give you simple regular forms. Sometimes they'll trouble you. Sometimes they'll give you something like this. Okay, please answer this question, sir. What is the answer for this? Please answer this. Extra question. Of course, I will be using this little later. Please answer this question. Okay, wonderful. Yeah, who is answering this question? Who is answering? n by 2, I less than or equal to n, I is equal to I into 2. What is the answer? See, first remember the standard rules. If any problem fits into that or is of that particular form, directly write the answer. Otherwise, you have to follow your regular methodology. 12 problem, please say me. Kannababu. Okay, I'll give you time for the other people to solve this. Now look here, sir. Kannababu, you need to take this rule which I discussed yesterday. For I is equal to 1, I less than or equal to n, I is equal to I plus 1. I plus 1 you do it, I plus 2 you do it, I plus 3 you do it, or I plus any constant you do it. This loop iterates n times. In place of I, if you get j also same story. If you get k also same story. So this is n times, this is n times, this is n times. Because it is nested loop, just to multiply them, n into n will be theta n cube. That's it. Okay? Yeah, who is answering this, sir? Next extra problem, important, interesting. Such problems are very interesting for GATE point of view, sir. Okay? See, in GATE, what they do is they make a small twist in the story. They're all simple problems only. And what happens? We only read here, but people don't identify the initial value of I, and the problem starts. Am I clear? So that is where people do mistakes. So who is answering this question? Who is answering this question? Oh, is it so difficult? So let me solve this. I is equal to n by 2. Every time you are multiplying by 2, n by 2 into 2 is what? N. One iteration it enters, second iteration it will come out of the loop. That is, second iteration it won't enter, just constant times. So the answer for this is theta 1. Good, Kannababu, no problem. Okay. So you can ask me any doubts, my dear friends, any repetitions, I don't mind. See, just need to put little extra effort when you are not following. Put complete concentration, try to hear, you will get it. They are not difficult, sir. Okay, generally people are worried about this and all this mathematical jargons, they are worried about it. They are not difficult, simple things. Okay, wonderful. So the next problem. So no one answered that question, so next problem I am going. X is equal to 0 and 3 nested loops. Are they dependent or independent? Still I am at 13th problem only. Now if you observe this, the outermost loop iterates how many times? I is equal to 1, I less than or equal to n, I is equal to I plus 1. Regular rule, first rule, n times. Theta 1, wonderful Fatima. Is it going very slow? The delay is too much or what? Good Fatima, wonderful, perfect answer Fatima. Next one, here j is equal to 1, j less than or equal to n, j plus j is nothing but 2 into j. Rule 2. So for rule 2, how many times the loop iterates? Log n times. Now the third innermost. Again it is regular first rule only. This is rule 1, this is rule 2, and this is rule number 3. So what is the answer for this? N. So the answer for this is, multiply them. Theta n into log n into n. So what is the answer, sir? N square log n. Is the idea clear? Wow, wonderful. Kajal Mandal, wow, super. Good, perfect. They're all simple problems. But if you do a small mistake, they become a complex problems also. See, simple problems are most dangerous. Please remember. Okay, good, AB. Rocked again. Next one. Who is answering this? Yes, what is the answer? First outer loop and inner loop. Now outer loop is rule 2. Direct. Log n times. But inner loop is also rule 2 only, but instead of n square is here. Instead of n, what is here? N square. So rule 2 only, but in rule 2 what happens actually? Whatever constant I is equal to 1, I less than or equal to n, I is equal to I into c will be there, and here answer, that is number of iteration, is log n to the base c. Here n is there, then you get n here. But instead of n, if you get n square, instead of n, if you get n square, then what happens? Log n square you get it. So log n square times theta log n whole square. Perfect, perfect AB, perfect. So it is log. See, I told you now, there is a difference between log square n and log n square. It is not log square n. This one is not log square n, log n square. So what is the answer for this? Theta outer loop log n, inner loop log n square. But before writing only, here I simplify this, sir. I simplify this here itself. Okay? Log n square is nothing but 2 log n. Okay, you can base 2 also you can use now. Log to the base 2 also. Log n square is nothing but 2 log n. So this is equal to 2 log n. This constant can be ignored. Therefore, second one is also log n only, my dear friends. Log n into log n, which is nothing but theta log square n. Writing 2 here or here matters. Please remember, these are all silly mistakes which generally people do. Okay, they happily answer in the gate examination and they say, yes, I done it. And after coming home, they'll realize their mistakes, or after getting the solutions, they'll realize their mistakes. Such silly mistakes, most of the people do such silly mistakes. Am I clear? 14th problem, please say, okay. Rest of the people, I am clearing everything so that I can quickly redo this problem, sir. See, outer loop is rule 2. So log n times. Second loop, that is inner loop, is same as this idea, I or j is equal to 1 to n, j is equal to 3 into j. So for this, if it is n, it will iterate log n to the base 3 times. But instead of n, what is there? Instead of n, you are having n square. Then you get log n square to the base 3. So this is log n square to the base 3. My dear friends, if you do not know this formula, log a power b is nothing but b log a. This is another formula we should know from logarithms. See, I learn with video lessons under asymptotic notation, I done this mathematical prelims so that those who do not know this mathematical prelims can understand all the rules clearly. Okay? Or maybe some other time I'll come up with this mathematical prelims only on YouTube. Am I clear? Okay, wonderful. So it is log n square. This can be written as 2 log n to the base 3. It is also rule 2 only. Therefore, the answer for this is theta log n into, see, constants can be ignored. The other one also, log n to the base 3 also can be written as log n, because base of logarithm does not matter asymptotically. So the answer for this is theta log n square or log square n, my dear friends. Is the idea clear? Okay, thank you Kannababu. Never mind. See, I am doing the problems for you only. Am I clear? If I don't explain properly, what is the use of me here? Okay? So whatever small problem or big problem, I am doing it for you people only. Okay? If you watch more, if you like it more, then we come up with more. A simple logic, simple mathematics, my dear friends. Nothing more than that. Next one. Who is answering this? Okay, no problem. If it extends time also, we don't mind. What about this? Outer loop, inner loop, innermost loop. First loop, second loop, third loop. For first loop, simply apply rule 1. For second loop, simply apply rule 2. And for third loop, also same as rule 2. So it is n times, and it is log n times. Sorry, second one is log n times. No, even I am doing mistakes. Wonderful, sir. Theta n into log n square. Correct. So the answer for this is just multiply them. Theta n into log n into log n. Theta n log square n. If you have any doubts, please do ask me, sir. Please do ask me. So let us take the next problem. What about this? Same nested for loop. Instead of 2 into I, given I plus I, sir. So you can write 2 into I, 2 into j, 2 into k, no problem. Okay, don't get confused. So all are rule 3 only, no other twist. Suppose twist may happen here or here also. So see the entire loop, initialization condition, looping condition, increment condition. Everything see carefully whenever you solve this nested loop problem, sir. The twist may happen here or may happen here also. But here no twist, we are happy. So this is log n, this is log n, and this is log n. So the answer for this is theta log cube n. Sir, we are enjoying your class. Please continue whole algorithm on YouTube. We will definitely get good rank in exams. I will try to come up with more classes on algorithm, my dear friends. Algorithm is a natural subject for me. Okay. So definitely I will come up with more sessions for sure. Okay. For sure. I already completed, recurrence relations. Okay. How to think recursively. That is one of the important concept for those who want to learn algorithms. Okay. Almost 6 lectures I done on how to think recursively. So you can see in the computer science listing. Am I clear? In that you will find it. And now it is how to start algorithm, asymptotic notation together with time complexity. Again I am solving, tomorrow also I will come up with same time complexity problems. And Saturday, Sunday I have other sessions. Okay. Then Monday, Tuesday I am coming up with solving recurrence relations. Am I clear? Solving recurrence relations also I start, my dear friends. Okay. And I try to see the courses or classes, whatever I am taking, they will be linked with each other. Am I clear? Thank you. Thank you. Thank you. Next one. Perfect. Next problem. Yeah, what about this? What about this? This is rule 1. This is also rule 1, but this is rule 1 but twist in the story. Rule 1 with a twist in the story. Am I clear? So what is this? This is simple rule 1, so n times. This is also n times. See, actually if it is n, it is n times, but you are going up to n square, therefore it will be n square times. So the answer for this is theta n into n square, which is theta n power 4. Theta n power 4. Simple. Correct? Perfect, AB. Perfect. Next problem. Yeah, next problem. Who is answering this? Same story. Now I given it for 2 loop variables. For j there is a twist. For k also there is a twist. See, now what we need to do is, for practice you don't have to go anywhere. You learn different simple loop conditions. No, you combine that with this nested loops. All those conditions if you combine, you get so many problems. The entire day you can do that problems only. You can just combine. Here because I have to type everything, so I just type in the sense, of course my SMS will help me for that. Now I have to come up with this much work. Okay, otherwise what happens, I randomly come up with some for loops. Am I clear? That you can do it. If you know all the basic linear loops, you can easily extend that idea for nested for loops, my dear friends. Thank you, AB. Thank you very much. Good. Now this one is going n times and this one n square तक जाता है. So it is n square times, and this is next one is also n square times. So what is it? Tn is equal to theta n into n square into n square. Theta n power 5. Okay? Wonderful, 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 Fatima. Wonderful, beautiful. Perfect, perfect. That's it. Okay? See, my dear friends, these concepts are not difficult. Generally, if you misunderstand anything, things get complicated. कोई भी concept ऐसा नहीं है complicated है simple ऐसा नहीं होता है. Misunderstanding concept is what we need to avoid. Okay? Generally, what we say, if you don't understand a topic, okay, instead of troubling the concept, ignore it or properly try to understand. Am I clear? Don't misunderstand a concept. Simple. 15 please. Oh, Kanna Babu, kahan pe? We'll see. क्या दिक्कत है 15 में? See, here it is same rule, na? See whether it is 2 into j, 3 into j, 5 into j, same story. These are all rule 2's only. Rule 2 takes log n times. This is also log n only. Okay? Clear? Same story, sir. Same rule 2. Rule 2, whether you have 2 into j, 3 into j, log n only. Similarly, 5 into k, 6 into k, 100 into k, 1000 into k also log n only. No problem. Asymptotically, log n only. Hope you understand. Dependent nested loop. So, see, actually I come up with so many problems, but I already, completed my time, my expected time. Tomorrow also I'm coming up with remaining problems and dependent nested loops also I'll be doing it. Dependent nested loops, उसको solve करना पड़ता है, and there is a small trick भी है, that also I'll explain. Dependent nested loops के लिए एक trick होता है. So if you use that trick, you cannot write theta, you have to write big O there. Okay, that I'll explain tomorrow. Am I clear? Yeah. What is the answer for this? I think we completed this. ये same है ना? हाँ same है, but here it is k plus k है, 2 into k. This is 2 into k. This is n times, rule 1. This is n times, rule 1. Second one, here there is a twist, n square times. The interesting part is the third one. See, third for loop, the innermost loop I am writing separately. Please see this carefully. Earlier I think I done it, but again we'll see this. K is equal to 1. K less than or equal to n into n means n square I am writing. K is equal to 2 into k. So whenever you are multiplying the k value by 2 or some constant and incrementing the value, in such cases, it will iterate how many times? Log of this number, whatever this value, log of n square times. So this outermost will be log n square. But log n square is nothing but 2 log n, and we can ignore the constant so that it is also log n only. Therefore, the complexity for this is theta n into n square into log n, which is nothing but theta n cube log n. Perfect. AB, perfect. Am I clear? Yeah, theta n cube log n. If you have any doubts, please ask me, sir. Good, good. Yeah. So what I do is take up this problem. From 20, the remaining problems I'll do it tomorrow and together with dependent nested loops. Dependent nested loops. Or we'll do some more problems today itself. N. Which one is n, sir? You give an answer for any particular one. Yeah, this is n. This is n square. Okay. Yes, yes, Fatima, perfect. Theta n cube log n. Perfect, Fatima. Perfect. Great. Super. Correct. No problem. No problem. Correct. Anyone? Any doubts? So we'll do the remaining problem from here. 4-5 interesting problems are there. We'll do one more interesting problem, that is also tomorrow, together with the idea of a dependent nested loops. We'll do tomorrow. So if anyone gives answer for this, we'll stop it here, and the explanation for this will be given tomorrow in the next class. So almost 20 problems. See, 200 problems also you can do. Just you need to understand the looping conditions. So I quickly tell you the rule 1. Actually, two ways it will be. I is equal to 1, I less than or equal to n, I plus or I is equal to I plus c, or I plus is equal to c. Or in the reverse direction. What is the reverse direction, sir? For I is equal to n down to 1, I greater than or equal to 1, I minus is equal to c. So from 1 to n or n to 1 with incrementation of a constant will always gives you theta n complexity. This is the first rule. Yeah, tomorrow I'll continue Skandababu. Okay, the remaining problem. This solution I'll continue tomorrow at 8 p.m. Rule 2. For I is equal to 1, I less than or equal to n, I into is equal to c. So constant multiple you are multiplying every time, and you are reaching the value, higher value or downside also. For I is equal to n and up to 1, by dividing a constant every time, the complexity which you get is theta log n, my dear friends. And the third rule, of course I not used, correct sir, theta n square, please say so n into 2 power n. Simple. Yes, perfect sir. Yeah. Rule 2 is for I is equal to 1, I less than or equal to n, and what is it? I is equal to I power c. Or generally here we don't take 1 because log 1 will be 0. So 2, some 2 constant or some other. Here you can use 2, 3, 4 or any other constant, my dear friends. So this one, or I is equal to n, I greater than or equal to 2 and cth root of I, whenever you get, the complexity would be log n. And here it is base c, and here it is, it is base c, and here it is, first one is base 2, this one is base c. That's it. So these are the rules which I given, my dear friends. Perfect, Fatima, perfect. So these are the 3 rules. Again, you quickly see this. Am I clear? And tomorrow I'll continue, my dear friends. So answer for this already given by my dear friend AB, which is n square into 2 power n. Please check this. Tomorrow I start with the same problem, sir. Why, Kannababu? Which problem you want me to say? How are getting log n? Which one log n, Fatima? See, this is 2 power n, sir. It is going with a simple increments plus 1, plus 1, plus 1. 20 problem you want me to say? Okay, अभी आंसर दे देता हूँ. Okay? Tomorrow you should come and tell me the answer. ये rule 1 n होता है. ये भी rule 1 n ही होता है. But ये भी rule 1 ही है. But you are going up to where? Going up to 2 power n. Not up to n, 2 power n. So it is 2 power n times. Therefore it is n square into 2 power n. Simply n into 2 power n. Nothing more than that. Fatima, log n is wrong. Yes sir, now it is clear. Kanna Babu, rule 1 ठीक से याद करके आ जाओ. Am I clear? Got it? Yeah. So this is same as this rule only. Instead of, if it is n, theta n. If it is 2 power n, that is exactly what happened here. Therefore it is 2 power n. In this case you get 2 power n because of that. 2 power n times because of that. I solved for you, my dear friend. Okay? And stop saying that many times, Kanna Babu. You say once, I understand. Okay? Don't say same thing again and again. That is called spamming. Okay? Please stop doing that. Okay, I'll give you the answers. I am here to clear your doubts or to say the answers. Am I clear? Don't unnecessarily strain yourself. Copy paste. Why that many times? Am I clear? Don't trouble your hands. Do work. Solve problems. Am I clear? That's all for today, my dear guys. If you have any other doubts, you can ask me. That's all for today. I am waiting for your final doubts. Thank you, Abby. Thank you. Keep watching. Okay, and subscribe to BP app also. There also under Learn with Video Lessons we have more videos, my dear friends. Of course, here also I will be coming up with okay. Here also I will be coming up with more and more topics for sure. Okay, you please attend the classes. I will come up with more and more for sure. Am I clear? If you have any specific topic you want me to discuss under algorithm, please mention that. That also I will come up. Am I clear? Yeah. Hopefully there are no doubts for you guys. Thank you for attending my class. Okay. Thank you for today. Thank you. Yeah. We'll call it a day.